All right, at the beginning of 2002, the coyote population in a wilderness area was estimated at 200. By the beginning of 2004, the coyote population had increased to 250. A park ranger estimates the carrying capacity of the wilderness area is 500 coyotes. So, again, the carrying capacity represents an estimate by some person who would have some knowledge of the area. So the park ranger, of course, will be the guy. If we get this population above 500, problems are going to start happening. Okay? We want to use the given data to determine the growth rate constant for the logistic model for this coyote population, logistic model. So as soon as you see the words logistic model, we're going to be using the logistic growth formula, which again is P of T equals C over 1 plus A e to the negative BT, where A is equal to C minus P sub 0 over P sub 0. Okay, so use those together all the time because you have to find A in order to use P of T. All right, so if I start picking stuff out of that information, first off, I'm going to say T equals 0 represents 2002. So the initial year is 2002. Always let the first year they mentioned be year 0. All right, so if I establish that P sub 0 is equal to what?
Sub 0.
What's it?
The initial population,
Yeah,
200, right?
That's
And in 2004, so how many years has passed?
2.
Starting at 2002,
Yeah, 5.
so T equals 2 years, right? So basically what I'm doing is I'm picking out all the stuff I can out of these two formulas, right? So after 2 years, I know the population after 2 years, so P of 2 is equal to 250, right? So they're going to give you the initial population, they'll give you the population after a certain amount of time, okay? So the initial population tells you what the beginning year is. It also tells you what P sub 0 is. The ending population, you can determine how many years have elapsed and how many more things there are, okay? And if it's grown, it's a growing, right? If there was 150, then it's a decreasing population. Okay. Next, if I look at carrying capacity, in this case, according to the park ranger, is 500. Right? That's all I really know, right? Nothing else up there. So I know C, I know T, I know P sub 0. I can find A because I know C and P sub 0, right? So I can get A equals something. So if I get all this stuff figured out, I know this, I know this, I know this, I know this, and I'm going to know this. Again, this isn't as important once I know A, right? So if I know these 4 things, so highlighting what we know this, and this, and this, and this. Notice the only variable left over is B, that growth rate constant. So again, we're picking stuff out of the equation, or out of the words, to use in the equation in order to find something we don't know, which in this case specifically is the growth rate constant. They're going to ask you that quite often in these logistic growth models, because that's what you can't determine. You can count the coyotes and you can, each year, and you can make the estimation for the carrying capacity. You can do all that stuff. You don't know what the growth rate constant is until you get all that data. Okay, so if we move on to actually do this, obviously we need to find out what A equals. So I take the carrying capacity 500, subtract the initial population 200, and divide by the initial population 200. That comes out to 300 200ths, better known as 1.5. As long as it comes out to a friendly decimal like that, I'm fine with decimals. Otherwise, I'd prefer a fraction. Okay, fractions are much more accurate than rounded, repeating or even non-repeating decimals. So 1.5 is fine since it's a nice terminating decimal. We can use that. So I'm going to substitute these 4 values into the logistic growth model in order to determine the carrying capacity now. So if I take all that information there, P of T, which would be 250. P of T is always based on some number of years, so the fact that this says P of 2, P of anything, as long as this matches that, is legal to put in there. So this is P of T as long as that's T. All right, so 250 is P of T. The carrying capacity, as we said, is 500. That's going to go over 1 plus 1.5 e to the negative b times 2. Just putting 250 where P of T was, putting 500 where C was, putting 1.5 where A was, putting 2 where T was. And that creates this equation here that has this structure. Now, one thing you gotta be cautious about in solving equations is you do them properly. Something that always happens on these problems is there's a cross multiplying happening here. Now, one thing I'm gonna make you look for, I want you to look for is this. This is a proportion, right? Cancellation horizontally or vertically is legal in a proportion. And anytime you can reduce things, it's helpful in these problems. 250 and 500 reduced down to 1 and 2. That doesn't happen all the time, but it happens often enough you should look for it. Okay, even if you can't get it down to a 1, if this was, let's say, 400 and that was 500, make it 4 and 5, that's better than 400 and 500, right? So the fact that we have the ability to reduce it is worth doing. If I cross multiply at this point, I'm going to get 1 times all this stuff, so it's going to be 1 plus 1.5 e to the negative 2b. I'd rather call it negative 2b than negative b times 2. All right, that negative 2b is the power of e, right? And that's going to equal 1 times 2, which equals 2. So then I'm going to get 1.5 e to the negative 2b is equal to 1 if I move the 1 over here. You always want to get e to the power first, then log both sides. Next, I've got 1.5. I'm going to call it 3 halves at this point. Again, anytime you get a repeating decimal situation where you're going to have to round, go fractions on it. So if I divide by 1.5, you know, it works also. But 3 halves, if I multiply by 2/3, 3's cancel, 2's cancel. So I get e to the negative 2b is equal to 1 times 2/3, which is 2/3. Again, if you go 0.6667, now all of a sudden you're rounding stuff, and it's not going to be as accurate as the fraction. So e to the negative 2b is equal to 2/3. Divide both sides. Oh, sorry, I got to log both sides first. So I'm going to log both sides. If I do ln of both sides, I'm going to get the power on this side. Same reason it has been every time. Doing ln of e to a power. That's log base e, that's base e, so you get the power out. So I'm logging that side. I'm going to get natural log of 2/3 on this side. Divide both sides by negative 2. And just like that, we've got an expression there that equals b. Then I should evaluate it. So I'm going to do ln 2 divided by 3, end parentheses, divided by negative 2. And we get positive 0.2027. Going back to the original problem, what it asked me to do. It said, use the given data to determine the growth rate constant for the logistic model. Okay? They aren't asking for the logistic model, but in part B, they're asking to use the logistic model. Okay? So that's the answer to the question they asked me. Quite often they'll ask you to do this. It'll say, find the logistic model. Okay? And the fact that question B is asking me to use the logistic model tells me that I want to create one. Okay? The logistic model just means we go back to here. I want to leave P of t and t as my variables. That's what I want to be monkeying around with. So if I can figure out what year it is, I can figure out what the population is for any given year. What I want to know is what A, B, and C are. So to create a logistic model, once you know A equals something, C equals something, and now B equals something, once you have all 3 of those numbers, the logistic model just simply is this thing with A, B, and C inserted. So P of t is equal to 500 over 1 plus 1.5 e to the negative 0.2027 t. That's the logistic model. That's what they usually ask for. In this case, they just ask for the growth constant, but they usually say, what's the logistic model? On the test, the problem that involves this, I ask for the logistic model in part A. Right? I can't do part B without this anyway, so, I mean, even though they didn't ask for it, I have to find it anyway. All right? So, going on to part B, use the logistic model determined in part A to predict the year in which the coyote population will first reach 400. So, all they're asking me to do here is make this equal 400 and find out what year it is. Okay? So, if I put P of t equals 400, put that over 1, equals 500 over 1 plus 1.5 e to the negative 0.2027 t. I didn't do this on purpose, I didn't just realize that, but notice the 400 and 500 thing I said. It's the exact same problem that we just did. Okay, if you're trying to find out the population, when the population occurs, it's the same exact structure. The only difference here is instead of negative 2 times that, I've got negative 0.2027 times that. The unknown is still in that spot, so the work involves the same. And just for the sake of making it easier to see, I'm going to copy that, go to a new page. Right, so that's what I'm trying to solve. So again, solving it the same way, reducing first, 400 and 500 reduced to 4 and 5. Again, it doesn't get down to that one level this time, but at least it's easier. If I cross multiply 4 times this thing, 4 times 1 is 4, 4 times 1.5 is 6, e to the negative 0.2027t, and 5 times 1 is 5. Be very careful that this is term 1, this is term 2. When you do 4 times this, it makes 6. You've already multiplied the whole term times 4. You don't have to do another 4 times the e. Okay, so it's just, all that stuff is grouped together as one object. Once you multiply by 4, it's done. Then if I move the 4 to the other side, I get 6e to the negative 0.2027t is equal to 1. Divide both sides by 6. Again, my first priority if I'm trying to solve an exponential expression is get the power structure equal to everything else. No numbers in front of it, no numbers added or subtracted from it. So e to a power equals number. Now I log both sides. And then finally divide by negative 0.2027. And we can determine then, if we type in ln 1/6, in parentheses, finish the log, divided by negative 0.2027, we find out that it took 8.84 years. So the question, going back to the other page there, looking at it, in what year will the coyote population first reach 400? So it's into the 8th year past the beginning, right? But not quite to the 9th year. So this is a truncate situation to find out what year it is. It's 2000 and whatever until it gets to 9, then it jumps to the next year. So if I take 2002, the beginning year, and add the number of years truncated to that, we get 2010 will be the first year the coyote population reaches 400. It would happen towards the end of the year. 0.84 is getting towards, September, October level, but they didn't ask that. They said what year does it happen in? During 2010. All right. On the test, that's what question 12 looks like. I'm asking for the red instead of the blue, so I'm asking for the actual model instead of just the growth constant. Okay. But I asked for the growth model, and I asked you when the population first reaches a certain amount. The other thing I could ask, maybe I ask what's the population in 2010?
So it's,
If it says 2010, then let t equal 8, substitute 8 right there, and then work it out. That's the other thing I could be asking for. The other thing it asks for the bonus on this, when does the population first reach whatever? What year would it happen that it first reaches this level? So then you can just do what we did there. The other way of doing it is this. Go to y equals, clear this out, and type in your equation. So 500 divided by parentheses 1 plus 1.5 e caret negative 0.2027x, end parentheses for the e, end parentheses for the division. Go to my table and just start typing in years. Year 1, 224. Year 2, year 3, year 4, year 5, year 6, year 7, year 8, year 9. Okay, we can see year 9 is 402, so it happened in year 8. Hit 400. By the time it got to 9, it was over 400. That means sometime during year 8 it was at 400 exactly, right? When's the population first reach 500? Getting close, 498.29. 499.77. So that's 500, right? Rounded up. So if I went back 39, 499.72 still rounds up. Somewhere in the 30s. So 31, nope, 32, keep going, 33, 34, 35, almost. Year 37, it's over, right? So that means sometime during year 36 is when it happens. So 2038 would be the first year to hit 500, and then it remains 500 from that point forward. Okay, but again, on the test, on the bonus, I think I asked for a number less than the carrying capacity. So at some point it happens. So again, the year it's over, the year before is the year it happened. So that's how you handle that.